So this leads to an internal question. You know how to find a correlation coefficient now, either with Excel or with StatCrunch. Personally, I prefer StatCrunch. I think it's much easier. That's up to you, right? But how do you know if your correlation coefficient is strong enough to imply a linear relationship between the two variables? And the short answer is you don't. You can't. There are other things that you want to judge. But the long answer is, well, you can sort of look at the correlation coefficient, but it's not the only thing you should be looking at. So what we're going to do here is look at the critical values for correlation coefficient and gauge whether our value is strong enough. So this is what we're about to do is only one test for a linear relation. See that? There are others, and the one that we're about to do isn't the best, but it's just all we're going to have for the current moment. So if you look at our math scores, how do we determine whether that's strong enough? Well, the first thing you do is step one. You take the absolute values. So step one, absolute value, which is vertical bar, right? Vertical negative 0.687 is equal to 0.687, right? Absolute value just turns it positive. Then you look for the critical value, step two. The critical value is equal to, now our n was how big? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so there were 13 schools. So n was equal to 13. So the critical value is equal to 0.553. It's right here, right in the center. All right, so if that's the case, step three, if the absolute value of the correlation coefficient is greater, see that? If the absolute value of the correlation coefficient is greater than the critical value, we say that a linear relation exists. 0.687 is greater than 0.553, so there appears to be a linear relationship between the two variables. There we go. Now, again, this test that we just did is not the most rigorous. There are going to be some other things we're going to do. So one thing is to always look at a scatter plot and be sure to that the data looks linear. And again, I showed you how to make a quick scatter plot. You just highlight the data, go to Insert, Scatterplot, right there. And then you can fiddle around with the values for the axis titles and chart titles and such. Another way to do it is in StatCrunch. So if you go to StatCrunch and you've got the data and you go to Graphics, Scatterplot. Your X variable is free reduced lunch. Your Y variable is passing math. Next. You want points. Next. Do you want to give it any labels like % on free reduced lunch? And this was the % passing math test. Right? And if you want to give it a title, you can say free reduced lunch, and it's effect on math scores. Probably wouldn't do that. Reduced lunch versus math scores. Do you want any grid lines on it? Right? I don't. So, but if you did, you could put them in there. I mean, here, I'll put them in. That's fine. Okay. Next. Don't worry about that. Just click Create Graph. And there it is. And you can see there's some faint grid lines in there, and there's that scatter plot. It's actually the same plot that Excel made. It's just on a different scale. So instead of going all the way down to 0, StatCrunch didn't do that. Oopsie. It's right here in my Java. Right here, sorry. StatCrunch started at 50. Okay. So you can fiddle around with options when you're messing around with making the scatter plot in the first place. You can fiddle around with what you want your scale to be, and then of course you could always copy and paste this into, well, Excel, Word, wherever you want to put it. Okay, so that's another way to gauge how strong that relationship is. And then we're going to learn some other values, namely looking at a residual plot, which we'll talk about in section 4.3, and there's other stuff in chapter 14. All right. Checking the critical value, by the way, is what we just did here on this page.